Hi, our goal today is to gain a better understanding of three-dimensional solids. More specifically, we're going to be looking at the two-dimensional shapes that we get when we cut cross-sections from a three-dimensional solid. A cross-section is the region formed by the intersection of a solid and a plane, or a straight slice through the shape. Everyday real-life examples of cross-sections are slices of bread or cheese cut from a block. We need to be able to describe the shapes that we would find if we made parallel or perpendicular cuts into a three-dimensional solid. Since this can sometimes be hard to visualize, we're going to actually cut into some solids, observe the cross-sections that we create, and then try to make predictions about the cross-sections that we could make in any 3D solid. We will be making horizontal cuts that are parallel to the base of the solid, and vertical cuts that are perpendicular to the base of the solid. Alright, to begin, we'll start by looking at a rectangular prism. In your mind, try to imagine the shape that we would get if we cut through the solid horizontally, parallel to the base. Okay, so we've made the cut, and as I separate the two sections, I can see that the cross-section would be a rectangle that is the same shape as the base of the solid. I'm going to repeat the process, only this time I'm going to make a cut vertically, perpendicular to the base. This time, as I separate the two sections, I can see that I still have a rectangle shape, but this one is longer and matches the side of the original prism. If I were to repeat this experiment with a cube, which has 6 equal faces, I would notice a different set of cross-sections. For this solid, all the parallel and perpendicular cross-sections would look the same. For shapes that are not rectangles, the cross-sections can get a bit more interesting. For instance, with this triangular prism, the perpendicular cut creates a triangle like we see on the side face of the solid. The parallel cut, however, creates a rectangle that matches the base of the shape. A cylinder is like a prism with a circle as its base. The parallel cut creates a circular cross-section. The perpendicular cross-section, however, is slightly less obvious. When I make a vertical cut, it creates a rectangle. And this shape is a lot like the shape of the paper you would use to wrap around the can. Our next three-dimensional solid is a pyramid. We can see with a pyramid, the perpendicular cut creates a triangle, just like on the side of the solid. If we make a horizontal cut through the pyramid, this creates a different shape. It creates a rectangle, just like the base of the pyramid, except smaller. The cone is a lot like the pyramid. The perpendicular cut creates a triangle. The lateral cut, or horizontal cut, creates a circle. This circle is the same shape as the base, except smaller. A sphere is a lot like a cube. No matter where you cut it, you'll get a circle. If you cut straight down the middle, you'll get the largest possible circle. If you cut anywhere else, you'll get a smaller circle. When trying to imagine the shape that a cross-section will create, it can be helpful to think about the faces of each three-dimensional solid, or the net that would create it. Hopefully, as we've gone through this investigation, you've started to notice some trends. Cross-sections that are made from cuts made parallel to the base will take the shape of the base. Cross-sections that are made from cuts made perpendicular to the base will take the shape of the lateral side or face of the three-dimensional solid.